Hey guys, so in this video we're going to be going through how to graph rational function. These all come out of page 316 in your textbook. The directions say sketch a graph. However, you're going to have to do all of the things listed on the next page before you can actually graph it. So keep that in mind that with all of these, when it says sketch a graph, you have to do all of these parts. So get a sticky note, a note card, something that you can keep with you as you're doing your homework. Here's kind of the shorthand version of how to find all of this stuff. We wrote this in your notes as well. Vertical asymptotes, VA, you're going to set the denominator equal to 0. So whatever the bottom is, set it equal to 0. You may have to factor, or you may just be able to solve a linear equation, a line. Next one, horizontal asymptote. This was the 3 different cases. If the degree of the numerator is less than the denominator, then you have a horizontal asymptote at y equals 0. If the numerator degree is greater than the denominator degree, then you have no horizontal asymptote. Now, if you remember, we talked about in class that doesn't mean you don't have a horizontal asymptote, but it means that you have a slant asymptote. Now, all the extent that you need to know with a slant asymptote is just write down there's a slant asymptote. Move on. If the numerator degree equals the denominator degree, so if they're the same, then you're going to have this y equals a ratio. The top leading coefficient over the bottom leading coefficient. And this will actually be in the next example. Thirdly, the y-intercept, set the numerator equal to 0. So the vertical asymptote is the denominator equal to 0. The x-intercept is the numerator equal to 0. Y-intercept, because you're letting x equal 0, is going to end up being the top constant over the bottom constant. And remember, constant just means that there is no x's associated with it. It is just a number. And then lastly, a whole. A whole is where you have a 0 on top and bottom. And so you'll see I have highlighted in blue. If you have a repeat of a vertical asymptote and an x-intercept, that is actually going to give you a whole. So anything that is repeated in the vertical or horizontal or vertical asymptote or the x-intercept will give you a whole, not a vertical asymptote. So we'll see that in an example. Alright, so here is our first example. This is actually number 48 in your book. F of x equals x squared minus 4 all over 2x squared minus 2. If you remember from way back at the beginning, f of x and y are the same thing. So where there's an f of x, you can replace it with a y. Now we're going to go through and do all of these parts with this equation. So the first part, the vertical asymptote. Well, we just wrote down, and we just hopefully remember that the vertical asymptote is where you set the denominator equal to 0. I see an x squared, so I'm going to have to factor. Well, I see a GCF, so you want to take that thing out first. I can actually now divide by that 2 and get rid of it, because 0 divided by 2 gives me 0. So get rid of that 2, factor this thing. It's a difference of squares. Solve it, you get x equals -1 and x equals 1, so I have those two vertical asymptotes, x equals -1 and x equals 1. Horizontal asymptote, you're comparing the degrees. So the degrees of these things are 2 and 2. So because I have the same degree, since the degrees are equal, 2 and 2, I do a ratio of the top leading coefficient over the bottom leading coefficient. So I have, well, I don't see a number out front there, so it's a 1. So I have 1 over 2 as my horizontal asymptote. Y equals 1 over 2. Thirdly, the x-intercepts. Well, if you remember from the previous screen, x-intercepts are where I set the numerator equal to 0. So I have x squared minus 4 equals 0. Difference of squares, so I'm going to factor it. Set each piece equal to 0 to finish solving. So I get -2 and 2, which will give me 2 x-intercepts. lastly, or second lastly, the whole. Whole you are looking for, are there any repeats in the vertical asymptotes or the x-intercepts? Is there a number that makes it 0 on top and bottom? Well, here I'm just comparing the vertical asymptotes, -1 and 1, x-intercepts, -2, 2. No repeated values, so I have no whole. Lastly, the y-intercept. So the y-intercept ends up being the top constant, -4, over the bottom constant, -2. So my y-intercept is -4 over -2, which gives me out 2. So there are all of my pieces. We're going to take all of that together and put it on a graph. So here are all the things on the left-hand side that we just found. On the bottom, I showed you how to type it in your calculator. The big thing that you have to remember is you have to add in a set of parentheses around the numerator and a set of parentheses around the denominator. If you don't, your graph will not turn out right. So let's graph all these. Vertical asymptote is going through the points x equals -1 and x equals 1. So I've got something happening there. I've got a horizontal asymptote at 1/2, so we're just estimating halfway through. I have 2 x-intercepts at -2, +2, and then I have a y-intercept at 2. So now from there, to actually fill in the rest of this, that is all I'm looking for, is that you have all of those points labeled. To fill in the rest of that, you are just going to type it into your graphing calculator, look at the screen, and then transfer that image onto your paper. So I typed it into my calculator, and there's the graph I found. Again, this is just a sketch. I'm not asking for very specific points other than the x and y intercepts. Alright, in this last one, I went ahead and did all the work to save some time, so I'm just going to kind of talk through it. So, found my vertical asymptote, which is where I set the denominator equal to 0. Solve that thing and I get -4. Horizontal asymptote, I'm comparing the degree, so I have a degree that is bigger on the top than on the bottom, 2 over 1. So I have no horizontal asymptote, but I do have a slant asymptote. And again, that is all that I need you to know. Not how to find it, just that a slant asymptote exists. From there, I did the x-intercepts, and I set the numerator equal to 0, difference of squares, so I factored I factored -4 and +4. Then I noticed when I'm checking my whole, there is a value that repeats. I have a -4 over here in the vertical asymptote and in the x-intercept. So as soon as I have a repeated value, I then throw out that vertical asymptote and that x-intercept, and it just becomes a whole. So I don't have any of those values counting twice, they just count as the whole value. Lastly, the y-intercept, set the constant over the constant because x equals 0, so that term goes away, and I'm left with -16 over 4, which gives me, that is not correct, gives me -4, not -6. So I have a -4 right there. So there is my y-intercept. I'm going to take all of that stuff, put it on the next screen, and graph it. Alright, so here's all of my stuff that we just found. Again, because there was a hole, notice I now have no vertical asymptote and I only have one x-intercept. So I'm going to type this thing into my calculator. Here is how you will type it into your calculator. This bottom part right here, again, you have to put one set of parentheses around the numerator. You have to put a separate set of parentheses around the denominator. So I plot all of these things and draw my lines and stuff. So I have a hole at -4. I'll wait till I get my graph and then I'll go through and do the hole. I do have an x-intercept at 4, which is right there, and a y-intercept at -4. So I type this thing into my calculator and it looks to me to be just a line, which is weird, but it is. Now this is the way I want you to handle the hole. You put the graph down. You see that there is a hole at -4, so you go to the -4 value. You go to the -4 value, you find where the graph is, and then you just draw a hole there. And then go back through and erase that little middle part so that it actually looks like a true hole. That is the extent of the hole knowledge that you should have. Go to the part of the graph where -4 is. So I went over 1, 2, 3, 4. Now the graph is down here, so I'm going to put a hole right there on the graph. So with your holes, you draw your graph first, whatever it looks like, and then you put holes on the graph where your X value is. If you have questions, send me an email, text me to remind. Good luck.